Welcome you all. In this session, we are going to discuss the breakdown mechanism in vacuum dielectric. Outcome: after successful completion of the session, the student would able to explain the vacuum breakdown mechanism. Vacuum breakdown. In 1000 type of discharge in gas described earlier, the electron get multiplied due to various ionization process and an electron avalanche is formed. In a high vacuum breakdown, even if the electrodes are separated by a few centimeters, an electron crosses the gap without encountering any collisions. Therefore, the current growth period to the breakdown cannot be due to the formation of electron avalanche. However, if a gas is liberated in vacuum gap, then the breakdown can occur in a manner described by Thomson's process. Thus, the various breakdown mechanism in high vacuum aim to establishing the way in which liberation of gas can be brought about the vacuum gap. These can be broadly divided into three. Three mechanisms are there to explain the vacuum breakdown. First one is particle exchange mechanism, second one field emission mechanism, and Klum theory. We know that the basic property of a perfect vacuum is it has no conduction and it acts as perfect insulating medium, these two things. So now here in these three mechanisms are here to see how the breakdown takes place in vacuum. First, let us discuss in detail about particle exchange mechanism. Particle exchange mechanism. In this mechanism, it is assumed that the charged particle would be emitted from one electrode under the action of high electric field, and when the impurities on other hand of electrode, it liberates oppositely charged particles due to ionization of absorbed gases. These particles are accelerated by a applied voltage back to the first electrode, where they release more of original type of particle. When this process becomes cumulative, a chain reaction occurs which leads to vacuum breakdown of gas. The particle exchange mechanism involves electron, positive ions, photons, and the absorbed gas at the electrode surface. Qualitatively, an electron present in vacuum gap is accelerated towards the anode, and on impact release a positive ion and see photons. These positive ions are accelerated towards cathode, and on impact each positive ions liberate B electrons and each photon liberate D electrons. Been illustrated here. You can see the a cathode and anode. So this is the cathode and this one the anode. So whenever a particle moves and hit on the cathode, so it liberates photons as well as electrons. The shaded dots shows the electrons and this one is photons. Field emission theory. So here there are two mechanisms. One is anode heating mechanism and other one is cathode heating mechanism. So first we are going to discuss the anode heating mechanism. This theory shows that the electron produced at a small micro projections on the cathode due to field emission bombarded the anode, causing a local rise in temperature and release gases and vapor into the vacuum gap. These electrons ionize the atom of the gas and produce positive ions. These positive ions arrive the cathode, increase the primary electron emission due to the space charge formation, and produce secondary electrons by bombarding the surface. The process continues until a sufficient number of electrons are produced to give rise to vacuum breakdown, as in the case of low pressure 1000 type of gas discharge. This is for anode heating mechanism. So here the vapor clouds are formed, and due to this the gas will be liberated between the gap. One is cathode heating mechanism. This mechanism, they near to the breakdown voltage of gap, sharp points on cathode surface. You can see sharp points will be there, and from there the particles will be revealed on the cathode surface, responsible for the pre-breakdown current, which generate according to the field emission process described below. This current causes relative heating at tip of point, and when a critical current density is reached, the tip melts and explodes, thus insulating vacuum discharges. Third mechanism is clump mechanism. So in clump mechanism, basically this theory has been developed from the following assumptions. Three assumptions are made. One is a loosely bounded, so the particles are loosely bounded, it is need to be assumed. Clump, that is what we call it as clump, on one of the electrode surface. On the application of high voltage, this particle gets charged, subsequently gets detected from the mother electrode, and it accelerated across the gap. The vacuum breakdown occurs due to discharge in vapor or gas increased by the impact of particle at the target electrode. Here you can see how the clumps, see initially the clumps is formed and it travels towards from cathode to anode. This is how these vapors vaporization, and now it forms a path for conduction. This is how the breakdown occurs by clump theory. Thank you.